So once again, good morning, everyone. We'll start with the second unit today, since we're not sure that how much of this extra time we will be availing. So we'll start with the second unit today, which includes the electrical circuit analysis. And the major contents for this particular unit includes the Kirchhoff current law, that is the KCL. Second comes the Kirchhoff voltage law, that is KVL. Third, we'll look at the mesh analysis. What is mesh analysis and how do we solve it? So we'll look at certain numerical examples for that as well. The next is the nodal analysis, which is used to measure the voltage at a particular node. And we'll again look at certain numerical examples for the same. Post that, we'll look at the series parallel connections. How do we solve these particular series parallel connections? And finally, we'll move to the star delta transformations. So whenever you have any doubts, feel free to unmute your mic and you're free to ask your question. Okay, so let's move ahead. So let's talk about KCL first. So KCL is basically, I'll not read through this particular thing, but for a particular junction, whatever current is entering the junction, at the same time, it would be the same amount of current which would be leaving the junction. So here we'll focus a bit on the nomenclatures as well. So if you say that the current entering is positive, so here you can see my I1 current is entering and I4 current is the current which is entering the junction. So considering that as positive, so my I1 and I4 is positive, and similarly the current that is leaving the junction, that is I2, I3 and I5. Sorry, I5 is also the current which is entering. So I1, I4 and I5 are the currents which are entering. So that is considered as positive, and I2 and I3 are the currents which are leaving. So they're considered as negative. Okay. So this is how we form an equation. And since we say that both the currents are equal, so that is why we are equating it with 0. Talking about your KVL, so let's consider this particular loop that we have taken here. We've taken here a voltage source Vs, which is a DC voltage source. You can figure it out with the help of the symbol that has been provided here, that it is a DC voltage source, which also has polarity of positive and negative, which also indicates that this is a DC voltage source. Apart from that, we have connected two resistances, resistance R1 and resistance R2. Since the current moves from positive to negative direction, so this is the direction of the current, and we have also considered the loop direction in the clockwise direction. So this is the information that is given to you. Now, when we talk about KVL, that is Kirchhoff voltage law, we know that the supply voltage is equal to the voltage drop in a particular circuit. So here, if we say that the voltage that is being supplied is only by one source, that is Vs. But when we talk about the voltage drop, there are two voltage drops that are happening in this particular loop. One is across your resistance R1, and similarly, there is a second voltage drop that we see across your resistance R2. So now when we try to form this equation, we see that the voltage Vs, that is the voltage which is provided to the supply, is equal to the voltage drop. So if you are considering this as positive, you'll take your voltage drops as negative. So that would be minus IR1 and minus IR2. So this would be equal to 0. Why? Because we say that the total voltage providers and the voltage drops should be equal. Now there are also certain sign conventions here. So we'll just go through this. When we have a loop the loop direction which we are following. So in that particular loop direction, when you cross a particular voltage, so if you look at this particular loop, you're moving from this end to this end, from this end to the bottom end, from bottom end to this end. And from here, if you're crossing this particular terminal, so you're crossing from negative terminal to positive terminal. So if you look at the bottom of the slide, it says if you're moving through a voltage source from negative terminal and the positive terminal immediately follows, you consider this voltage as positive voltage plus E. In the opposite case, if you're traveling from positive terminal to negative terminal, so when you're traveling in a particular loop and the positive terminal is immediately followed by the negative terminal, then you take this particular voltage as negative of E. Is this clear? Any doubts here, please ask. If anyone has any doubts, please ask. Okay, fine. Since don't see any hands raised or any questions being asked, so let's move forward in this. Now talking about the voltage drop conventions. So here talking about the sign conventions for your particular voltage drops which occur across your resistors. Now, if you are moving in a particular direction, that is the loop direction, the travel which is given is nothing but your loop direction. Now, when your loop direction is opposite to that of your current, you take the voltage drop as positive IR. But if you're traveling in a direction which is same direction to that of the current, then we consider that as negative IR, or the voltage drop is considered as negative. Now let us implement the same thing here in the loop that is given to us. The loop given to us is clockwise. Now starting from the top left corner, if I'm moving in this particular direction, which is the direction of the loop, now if you see the direction of the current is also same. Since both of them are same, you are taking this, since both the travel direction and the current direction same, we are taking this direction as negative. So that becomes minus of IR1. Okay. Now moving from top right corner to bottom right corner, in this particular branch, again, the loop direction says that we are moving from top to bottom. The current is also moving in the same direction. So here again, we'll take this voltage drop as negative. So that becomes minus IR2. So the same thing is written in the equation as well. And now, since there is no element from the bottom right corner to the bottom left corner, so there is no term that would be added to the equation. And now moving from bottom left corner to the top left corner, in this particular branch, you have a voltage source where you are moving from negative terminal immediately followed by the positive terminal. So you'll take opposite sign of this. So this would be plus Vs. So you can see in the equation you have plus Vs and this is equal to 0. So that is how you form an equation. Is this clear? Do we have any doubts in this particular section? How we write our equations? Okay, fine. So if you do not have any doubts, let's move ahead. The next are certain definitions. Now, since we are in short of time, I would like you to just go through these particular definitions whenever you get this PPT. Uh, so there are certain amount of elements which are called as active elements and passive elements. Basically, active elements are the ones they are able to provide you a certain sort of supply, and the passive elements are usually the consumers of the supply. And this is a particular network. Now, yeah, these are the two important definitions that I like to touch upon. First is a node at which two or more elements are connected together is called as a node. Where two or more elements are connected together is called as a node. Whereas for junction, it is three or more elements connected at a junction. Okay. Now, branch is a section or a portion of a network or a circuit which lies between two junction points is called as a branch. Next is the loop. Now we have seen the loop right now when we were applying your KVL. So again, the loop is any closed path in a network is called as a loop. But now if you have a loop which can be further subdivided into small loop and you keep on doing that, then you'll reach at a point where you cannot divide a loop into further sub loops. So that is called as a mesh. So mesh says it is the most elementary form of a loop and cannot be further divided into other loops. So that is what is a mesh. A mesh is a loop that is no further circuit paths inside it. Okay. So I hope these are understood. Now we'll talk about mesh analysis. So how you apply mesh analysis here? So mesh analysis applies to find the unknown currents. We are finding out the unknown currents in the different mesh that are created. Now it is applicable only to the planar circuits, which can be drawn using a 2D or a 3D. So okay, a mesh is a loop that does not contain any other loops. The current through mesh is known as mesh current. And assume for simplicity that the circuit contains only voltage source. So here we are not talking about any current sources here. If at all a current source is given to you, you need to convert that to a voltage source, which makes it easier for calculation. So again, now let us understand that how do we solve this. So let's see that a diagram is given to you. So let us assign first the mesh currents. So let's call this as I1, I2, I3, and I4. Okay, Dhvani, I have muted you. Students, please make sure that your mics are muted. You'll be asked to unmute the mic whenever you have any doubt or whenever a question is asked and you have to answer, you can unmute the mics. So, okay, moving ahead with the diagram. Here you can see that there are multiple loops can be formed in this particular diagram. But when we talk about mesh, there are only four mesh that can be formed. They're labeled as I1, I2, I3, and I4. Now, in this particular diagram, they have been labeled in this particular fashion. Although it is the choice of the person who is solving the mesh can number it in any particular fashion. They can give this as I1, this as I2, this as I3, and this as I4. So it is absolutely the choice of the person who solves this, how to figure this out. Now, once you have given the name to the particular mesh, you have assigned the currents to the particular mesh. Now what we'll do is we'll start applying KVL in this particular mesh. So when we talk about KVL, we already have a voltage source in a particular mesh. The rest is what you have is resistance. So what you will take is the voltage in terms of, if I want to write out voltage in terms of resistance, so it has to be the product of current and resistance. So if we talk about the resistance R1, the voltage drop V1 would be nothing but the current I1 multiplied by the resistance R1. That would be the voltage drop V1 in this particular diagram. Now we'll talk about the sign conventions later, whether this should be minus V1 or plus V1. We'll look at this at a later stage, but I hope this is how you apply KVL is understood to you. Once this is done, we form some particular equations and then we try to solve this. So let's see how these equations are formed. First, we'll talk about this particular mesh 1, which has the current I1 flowing through this. So now starting again from the top left corner, now there is no compulsion that you need to start from the top left corner, but it is usually advisable to start from the top left corner. So again, moving ahead, if I start from top left corner, I'm going in the direction of my mesh, where the mesh loop says this is in the clockwise direction. So I'm moving from top left corner, which is on the left side of R1 to the right side of R1. Now, if I see here, this is my travel direction. Also, the positive and the negative sign is given to you. So that means the voltage flows from positive to negative. So the current would also be flowing in this direction. So that is why we have this as minus V1. So you can see that in the equation you have minus V1. Now, when we talk about the resistance R7, when the current I1 flows through R7, please have a look at the current I1 and your branch R7, the branch which has the resistance R7. Now, I1 is not the only current which is passing through R7. Okay. There is also one more current I2 which is passing through R7. So we'll talk about this particular resistance as well. This particular current through the resistance R7 as well. But right now, when we talk about voltage, if this is given positive and this is given negative, so the current would move from positive to negative. So the current in resistance R7 would move from top to bottom, which is the same direction as that of our loop or say our mesh 1. So we'll take this also as minus V7. Coming to the bottom right corner and then moving to the bottom left corner of your mesh 1. So you are moving from negative terminal to positive terminal. So you are moving now the current would be moving from positive terminal to negative terminal and you are moving in a direction which is opposite to that of the current. So that is why we'll take this as plus V5. And from this point, coming to your original point from where we have started, if you see the top end, there is a positive sign. So indicating that it is at higher terminal. So the bottom terminal would, as it is, be negative terminal. So if this is positive, this has to be negative. So now if you move in this particular branch where you're moving from bottom to top, the first terminal that comes across is minus, immediately followed by your positive terminal. So minus to plus, as we have seen in the previous slides, this would be taken as positive Vs2. And since this entire loop, we have considered all the elements which are associated with this particular mesh, we take this is equal to 0. Similarly, talking about the second mesh, starting from this point and moving across your R2. So the current in R2, if you see the V2 positive and the negative is given to you. So the direction of the current would be from left to right in R2, which is also the direction of the mesh current I2. So therefore, we say that the current through R2 is from left to right and the direction of the mesh current is also the same. And since both the direction are same, we take the voltage as negative, that is minus V2. In the rightmost part, you don't have an element, so there would be no term associated with this. Talking about the bottom branch of my mesh I2, now here you can see that the mesh moves from right to left, whereas the current would be from left to right. Now, since both the directions are opposite, we'll take this as plus V6. And similarly, moving from bottom to top across R7, and the voltage drop V7 is given where the top end is positive and bottom is negative. So the current direction would be opposite to my mesh current direction. So that is why we take this particular voltage V7 as positive, which is equal to 0. Now, similarly, I want you to apply these particular uh, equations in this particular mesh I3 and I4 and please check whether you're getting these equations or not. If you have any doubts in understanding, please ask. Okay, now quickly implementing the equation in mesh 3, moving from the left side of R5 to right side of R5. Now you are moving the mesh loop in the same direction as that of the current. So the V5 would be minus V5. Moving from top of VS1 to the bottom of VS1, we cross the positive terminal first, immediately followed by the negative terminal. So that becomes minus VS1. No element in the bottom part, so no term to be associated with the equation. And lastly, moving through R3 from bottom to top as my loop direction or mesh direction. And the voltage V3 is also from positive to negative. So that is why the both the direction of the current and the mesh current would be same. So that is why we'll consider this as minus 3, which is equal to 0. And lastly, talking about your mesh 4, moving from left of R6 to right of R6, the direction is same as the current through R6 as indicated by V6. So that would be minus V6, moving from top of R4 to the bottom of R4. So my mesh direction and the current through R4 is the same. So we take this as minus V4. Similarly, the loop direction or say the mesh direction and the current through R8 are again in the same direction. So we take this as minus V8. And here in the last branch, we are moving from bottom of VS1 to the top of VS1. The top terminal already indicated as positive. So the bottom terminal would be minus. So moving from negative terminal to the positive terminal. So that would be taken as plus VS1. As far as voltage is concerned, if you have two terminals immediately following one another, if you cross the negative terminal first, you write this as positive. If you cross the positive terminal first, you'll take this as negative. In this case, moving from here to here, you are crossing your negative terminal first. So that is why you'll write this as plus Vs1. So I hope this is clear. Now here, these are the same equations that you have written in the previous slide. Now we are converting the voltage, which are the voltage drops, that is V1, V2. Then we have voltage drops, that is V5, V6, V7, V3, V8, and V4. Also V6. We'll start converting this in terms of current. And we'll let the voltage source VS1 and VS2 remain as VS1 and VS2. So here the voltage drop V1, if you look at the first equation, the voltage drop V1 is considered as I1 into R1. Since it is minus V1, it becomes minus of I1 into R1. I'm just indicating what is V7. The If it is minus V7, the minus sign remains as it is. When I talk about V7, V7 is the voltage drop in this particular branch. Now, when I'm writing the equation for my mesh 1, it would be I1 minus I2 because both the currents are flowing in opposite direction to each other in this particular branch R7. If you see, the current I1 is moving from top to bottom as far as the mesh direction is concerned. Similarly, the current I2 is moving from bottom to top in this particular resistance R7. Since the direction of both of them is opposite, so you take this as I1 minus I2 multiplied by R7. So that is the voltage drop you'll see here. Talking about the voltage drop V5, so again, you're writing about the mesh 1, the equation of mesh 1. So we'll take the current through V5 and the current through I3, both are in opposite directions. This would be I1 minus I3 multiplied by R5. Now, when you talk about the current through R7, when we talk about the mesh I2, so the voltage drop V7 would be written as I2 minus I1 multiplied by R7 when you are writing it for mesh 2. So if you figure out, you have V7 term as your last term in the equation. So your V7, since it is plus, you have the plus sign here. V7 for mesh number 2, the equation for mesh number 2, it would be I2 minus I1 multiplied by R7, which is equal to, fine. Now, this is equal to nothing but your voltage drop V7. Similarly, if we talk about the voltage drop here, now since there is only one current here, that is I2 flowing through your resistance R2, simply it would be I2 into R2. And since my V2 is negative, so I have my negative sign here, and V2 is nothing but I2 into R2. And similarly, talking about the current through this particular resistance R6, the loop is moving in the clockwise direction. And if you look at your current I4, again, it is moving in clockwise direction. So the current through resistance R6, I2 and I4 both are in opposite direction. If you are writing the voltage drop V6 for mesh 2, it would be I2 minus I4 multiplied by R6. The same can be seen here. It is I2 minus I4 multiplied by R6. But if you're writing the same voltage drop V6 for your mesh 4, so for your mesh 4, it would be I4 minus I2 multiplied by R6. So I'll give you a couple of seconds. Just please go through the equations that I have been converted for voltage drop in terms of voltage and resistance. So please go through this and let me know if you have any doubts. Marut, you are free to unmute and ask your doubt.
सर मैच टू वापिस से समझाइए ना.
Where you did not understand?
और I2 minus I1 into I2 minus I4 into R6.
That is
Mesh,
the mesh 4. Are you talking about the equation of mesh 4?
no, mesh 2 I2 minus I4 into R6.
Okay. I2 minus I. So when you talk about this particular mesh, you write the equation with I2 as your primary current. So if you see the current which moves from right to left in the resistance R6, correct? Do you understand this?
Yes,
Okay.
yes, yes.
And if you talk about the current I4, it is moving again in clockwise direction. But when we talk about R6, it would move from left to right in R6. So the overall current in the resistance R6 would be, when you write the equation for mesh 2, it would be I2 minus I4 into R6. That would be your V6. But when you are writing the equation for your mesh number 4, your I4 becomes the primary current. So it would be I4 minus I2 multiplied by R6. Why are we doing this minus? Because the resultant current is the subtraction of both the currents. Do you understand this?
Yes,
Marud, are we clear? Okay. Any
yes.
other doubts?
सर
Okay.
दोनों
Thank
एक
you.
ही डायरेक्शन में हो गए तो प्लस आएगा ना.
Yes. If both the currents are in the same direction, you'll have to add the currents.
ओके.
So let's say if this I4 is in anti-clockwise direction. So if this is an anti-clockwise direction, it would enter from the right end and leave at the left end as far as R6 is concerned. And this is in clockwise direction. So this current would enter here and again leave at this. So here both the currents would be added. So it would be I2 minus I4 multiplied by R6 if this particular loop is taken in anti-clockwise direction. Is this clear? Any further doubts? Okay. Thank you, Marut. Any further doubts? Okay, so now we'll move ahead of this. So since we have formed this four equations, so these are the four equations that we have formed. Now what we're doing is we'll open this particular brackets and we'll try to get all the I1, I2 and I3 terms together. And we'll take the voltage sources on the right hand side. So here what we see is you'll get I1, which is multiplied by R1 plus R5 plus R7. So you have terms with R1, you have terms with R5, and you have terms with R7. So we are opening this particular brackets for all the four equations, and we are taking the voltage sources on the right hand side of the equation. So just have a look at this. So this is how your equations would be formed. Please go through the equations. It's simply opening up the brackets and stacking I1, I2, and I3, I4 quantities together. Once you do this, you'll have the I1, I2, I3, I4 terms on the left hand side, whereas on the right hand side of the equal, you'll have the voltage sources. So once this is done, you can place this in form of matrix like this. Okay. So once you have done this, you can use your Cramer's rule for finding out your currents I1, I2, I3, and I4. So this is nothing but your resistance matrix, this is your current matrix, and this is your voltage matrix. So R into I is equal to V. So this is the equation that becomes common. Okay. So any doubts till this particular point, you are free to ask. Yes, Meet, please unmute yourself and go ahead.
ये जो सर आपने वो आर वाला मैट्रिक्स में लिखा है ना वो सर एक बार वापस समझे।
The resistance matrix, yes.
हाँ ये यही सर।
Hmm. So what is the doubt here?
वो सर हम वैल्यू पुट करते हैं ना जो आर की यहाँ पे वो वाली एक बार चेक करनी है उसमें डाउट
I'm not understanding the question. Can you please come over?
है। यस सर ये जो आपने आर में ये मैट्रिक्स लिखा है ना हमने R1 + R5 + R7 वाला वो
Hmm.
पहली तीन कॉलम में वो पता चल गया ये लास्ट में जीरो वाली है ना वो उसका पता नहीं चल रहा है वहां पे डाउट है।
So in the first equation, you don't have any term of I4. So this 0 is placed for I4. In the second equation, you don't have any term which has I3 in it. So at the place of I3, which would be multiplied by the I3, this is 0. This is just conversion of, see, you might have learned matrix multiplication. So here we are doing, the reverse process. We have the equation. Now we are separating that to the matrix form. Similarly, when you talk about the third equation, you don't have any terms with I2 and I4. So at the terms of which would be multiplied with I2 and I4, these places are taken as 0. And in the last equation, you don't have any terms with I1 and I3, so that places are taken as 0. When we talk about your equation of voltage in the second loop, you do not have any particular voltage source. So this is taken as 0. Is this clear? Meet?
यस सर यस
Have
सर
I tried to answer your question?
ओके
Any further doubts? Please ask.
नो सर।
Okay. Meet, can you please lower your hand as well? So just in case if you have any further doubts, we can address that again.
ओके सॉरी सर।
No, not a problem. Please lower the hand. Okay, good, great. So no problem so far. Shall we move ahead? Okay, great. Okay, fine. So now let's have a look at the Cramer's rule. How does the Cramer's rule work? Let's say you have three equations like this, where you have A11 into x1, A12 into x2, A13 into x3 is equal to B1. This is your equation number one. Second equation is A21 into x1, A22 into x2, A23 into x3, which is equal to B2. Similarly, A31 into x1, A32 into x2, A33 into x3 is equal to B3. Let's say these are three equations that you have. Now, The next what we'll do is we'll convert this into matrix form. So this is your A matrix, this is your X matrix, and this is your B matrix. Now, let's say I want to find out my X1, X2, and X3. So how I can do this is by using the determinants. So let's see how we can do this. So this is my A matrix. Again, this is X and the B matrix. Now, if I need to find out X1, X2, and X3, I can do this using D1 by D, D2 by D, D3 by D. For that, I need to understand what is D, D1, D2, and D3. Okay. So here you can see that the determinant of the matrix A is my D, replacing my first column with the B matrix, that is B1, B2, and B3. This would give me my D1, replacing the second column with my B matrix, that would give me my D2. And similarly, replacing the third column with my B matrix, that would give me my D3. So now when you do D1 by D, that would give you your value of X1. Similarly, D2 by D will give you the value of X2, and D3 by D will give you the value of X3, which is mentioned here. You can see this. Okay. So just by simply doing this, you can figure out the values of X1, X2, and X3. Any doubts here how we use this particular Cramer's rule? Any doubts here? Please ask. Because we will be using this Cramer's rule for solving the matrix. Okay, since I don't see any hands raised, let's move ahead to the numericals. Okay, so here is a question for solving this particular mesh currents I1, I2, and I3. And we need to figure out what is I1, I2, and I3. What are the values here? So let's start making the equations here. Now, the question what we, the diagram that we had seen earlier had the voltage drops and the positive and the negative sign of the voltage were given to you, which is not given here. So now what you do is you move from mesh 1 to mesh 2, then to mesh 3 in the direction of your mesh current, assuming it to be the same as the direction of the current in that particular mesh. Okay, so the loop direction and the current direction is same here, since the current direction is not given to you. Okay, so here moving from the top left corner for your I1, moving through your resistance 10 ohms, it would be minus 10 I1. Do you understand this? So this would be minus 10 I1. Now you have a branch which has current I1 as well as I2. But if you focus here, I1 is moving from top to bottom across your 5 ohms resistance, whereas I2 is moving from bottom to top in the 5 ohms resistance. So this would be I1 minus I2 into 5 ohms. And since we are moving in the direction of I1, so this becomes minus of 5 into I1 minus I2. Is this clear? Is this clear? Okay. Moving ahead to your 3 ohms resistance. Now you can see your I1 is again moving in downward direction. But if you look at the direction of I3, it is moving from bottom to top in the 3 ohms resistance. So now again, since we are moving in the direction of I1, says this would be minus of 3 into I1 minus I3. Since there is no element here in the bottom branch, there would be no term associated with this. And since we are moving in the top portion, on the leftmost branch from bottom to top, where we are crossing the negative terminal first, then followed by positive terminal. So when you're crossing negative terminal first, you'll take the opposite sign of that. That would be positive 50, which is equal to 0. So this is how your equation would be formed. So negative to positive, this would be plus 50, moving in the direction of the current. So this is minus 10 I1, then minus 5 of I1 minus I2 minus 3 of I1 minus I3 and here plus 50 is equal to 0. So I hope this is clear how we write the equations. Similarly, look at the diagram and write the equations for your mesh 2 and mesh 3. Try to write down the equations for mesh 2 and mesh 3. You have 1 minute time. Okay. So I presume you might have written your equations. Now let's just have a look at the equations that are being formed. Please check your equations, whether you are getting the same equations or not. Any doubts in the equations, please ask. Okay, thank you, Ayush. Thank you there. Okay, fine. So it seems that you have been able to make the equations. Now again, open your brackets and converting this equations in terms of I1, I2, and I3 and placing that in form of matrix. This is what you will get. Now you need to find the determinants and substitute the values. So we'll not get into that calculation as of now since we are running out of time. So I just would like to run you through the calculation. So the determinant would be 356. Your this delta R is nothing but D. Your delta R1 is nothing but D1, where you are substituting the first column with your voltage matrix or your B matrix, that is 50 minus 10 minus 5. So you're just substituting that here. Then your D2 would be substituting the second column with your voltage matrix. And your D3 would be nothing but substituting your third column with your voltage matrix. So this is what you get. And finding out your I1, I2, and I3. So I1 would be D1 by D. So that is delta R1 by delta R. Similarly, I2 would be delta R2 by delta R. And delta R3 by delta R would give you your value of I3. So this would be the equations and this is how you solve them. And this is how you can get to your answers. Okay. So once you already have the equations, try solving this uh, post this lecture session so that you have a clear idea of what we are going through this. So this is one of the same type of numericals which I would like you to go through this. You will be provided with the PPTs post this session is done. Once the chapter is completed, you will get it by your the instructor who is teaching you in your classes. So that particular faculty member would be sharing the PPTs with you. So I have a general practice that I share the PPT post the lecture is done or post the unit is being covered. And you just in case if you are into any other class, please make sure to collect the PPTs from the respective faculties who are teaching you this particular subject. So just have a word with them and ask for the PPTs. They would be more than happy to share this with you. Fine. Now, let's have a look at this particular diagram. And now I teach you a shorter method of making a matrix. It's usually called as a shortcut method for making the matrix. So let us just have a look at that. So when we talk about the resistance matrix, now I'm sure you are able to figure this out. The resistance matrix would be a square matrix. Since you have three currents, so the current matrix would have three elements, that is I1, I2, and I3. And the voltage matrix would again have three elements based on the voltage that they have in that particular mesh. So this is the kind of matrix you would be forming. Now, when we talk about the shortcut method, just have a look at this. So you'll have this matrix of 3 cross 3. Do you agree with me? The resistance matrix would be 3 cross 3. Similarly, the current matrix would be 3 cross 1, since it would have only three elements, that is I1, I2, and I3. And similarly, the voltage matrix would again be 3 cross 1 based on the amount of voltage it has in that particular mesh. Okay. So is this particular thing clear? Any doubt so far? Since we have three mesh, we have a resistance matrix which is 3 cross 3. We have a current matrix which has three currents, I1, I2, and I3. So if we have five mesh here, this would have been 5 cross 1. The resistance matrix could have been 5 cross 5, and the voltage matrix would have been 5 cross 1. Okay. So depending on the number of mesh, your dimensions of your matrix would change. Okay. Now, since I said that this is a shortcut method, you can form the matrix before writing the equations. So when we form this particular matrix, let us first start with the diagonal elements. So diagonal elements is R11, R22, and R33. So let's talk about R11 is nothing but the resistances which are connected with mesh number 1. So if you look at the overall resistance, that is 5 ohms and 3 ohms is the overall resistance which is connected with your mesh number 1. Okay. So my R11 becomes 5 plus 3, that is 8. So my R11 becomes 8. Similarly, when we talk about R22, that is the overall resistance connected with my mesh number 2, that is 3 ohms plus 4 ohms plus 2 ohms. Okay, 3 plus 4, 7. 7 plus 2 is 9 ohms. So this would be 9 ohms. And talking about the resistance connected to mesh 3, that is 2 ohms plus 8 ohms. So that is in total of 10 ohms. So I'll place this 10 here. Once this is done, we'll talk about the rest of the 6 elements. But before placing that, you have to place a minus sign with all the 6 elements. We'll talk about the value later, but first place this minus sign for rest of the all 6 elements. Now, This value that we'll place, okay, if you can see my pointer, the value that you place in the second column of first row, that is called as R12. Similarly, the value that you place here, that is the second element of your first column, that is called as R21, both would be same. Now that is nothing but the resistance which is shared by mesh 1 and mesh 3. So this, if you see mesh 1 here, mesh 2 is here, and the resistance shared by them is 3 ohms. So you'll have 3 here. Okay. Similarly, for mesh 1 and mesh 3, now there is no resistance which is common between mesh 1 and mesh 3. There is no contact between mesh 1 and mesh 3. So you'll take this as 0. Now talking about mesh 2 and mesh 3, there is one particular resistance that is 2 ohms, which is connected between your mesh 2 and mesh 3. So this becomes 2 ohms. This would be my I1. Next would be my I2. The last is I3. And now talking about the voltage vectors. So for the voltage vectors, again, we'll follow the technique that we have been doing. So starting the loop from the top left corner and moving in the clockwise direction. So if you see here, okay, before that, I'll just remove this spread of the ink so that it becomes easier for you to understand. Okay, moving the loop in the clockwise direction as the mesh direction is given, crossing the positive terminal first, immediately followed by the negative terminal. So this would be minus 5 volts. Then moving here, you have negative terminal first, immediately followed by the positive terminal. Since you are crossing the negative terminal first, you will take this as plus 20. So minus 5 plus 20, this would become 15 and plus 15 to be more specific. Similarly, talking about the second mesh, if you see, of crossing the negative terminal first, immediately followed by the positive terminal. So this becomes plus 5 for B4. Similarly, here this would be plus 5 for B3, and the same ways it would be plus 5 for B2. So 5 plus 5 plus 5. So overall, my this value would again be plus 15. And looking about the third mesh, starting from the top left corner of mesh 3, moving here. Now you're crossing the positive terminal first, immediately followed by negative terminal. So this would be minus 30. The same thing is followed here. Positive terminal immediately followed by the negative. So this would be minus 5. So minus 30, minus 5. So this becomes minus 35. Okay. So this is how you form your matrix using the shortcut method. If anyone has any doubts, please ask right now. If you have any doubts, please ask. No. Okay. Thank you. So now, once we have done this, now tell me what are we supposed to do? We have formed the matrix. What needs to be done next? Now again, you need to form this. You need to write your form your determinants D1, D2, D3, and D4. So your D1 by D would give you your I1. Similar, your D2 by D will give you your I2, and D3 by D will give you your I3. Now, talking about the question, if you read the question carefully, it says that sorry. By using mesh analysis, you need to find out the current supplied by each of the batteries. Now you know I1, I2, and I3 values. So here the current supplied by B1 would be as good as I1. But when we talk about the current supplied here, it would be I1 minus I2. So here you can see B1 is I1, by B2 it is I1 minus I2. When we talk about B3, that is this particular, it would be I2 minus I3. B4 would be as good as I2. So let's see this. So B3 is I2 plus I3. Okay, why is it B2 is I2 plus I3 instead of minus? Because here I3 you are getting the value as minus. Your answer is in minus. So this negative sign indicates that the direction of the current is opposite to your mesh current that you have assumed. So here, if we look at the diagram, we have assumed my I3, which is in clockwise direction, and the answer is coming as minus 3.13. So that means the value is 3.13, but the direction is opposite. So it is flowing in anti-clockwise direction. So when we say it is flowing in anti-clockwise direction, so that means the current through B3 would be I2 plus I3 and not I2 minus I3. Okay. So here this would be I2 plus I3. For B4, it is as good as I2, and as far as B5 is concerned, it is as good as I3. So this is how you solve these particular numericals, and that is how we can solve mesh analysis. So if you have any doubts regarding mesh analysis, please ask. Any doubts regarding mesh analysis, please feel free to ask. Okay. If you do not have any doubts, let me take you to one more question. I want you to form the resistance matrix, the current matrix, and the voltage matrix using the shortcut method for the question that you have on the screen. The mesh directions are given to you in the figure 3.9. Please go through this. We are not getting into the calculations right now. I just want you to make the matrix first so that we have a clear understanding. Since we have three mesh currents, I1, I2, and I3, the current matrix would be of the order of 3 cross 1. The voltage matrix would also be of the order of 3 cross 1. And the resistance matrix would be order of 3 cross 3. This is just for your information. Or you can also consider this as a hint. So please make the equations. I'll give you 1 minute's time to do so. Those who have completed can raise your hand. Whenever you're done, please raise your hand. Okay, so it's good to see that majority of you have tried to solve this and are getting the same as your output. Now let us have a look at the answers. You can verify your answers by this particular matrix. Are you getting this? If you're getting the same answer, please write in the chat box yes. If you're getting these answers, please write yes in the chat box. Okay, good, good. Dishit, good. Mehak, good. Prithvi, good. Okay, good. Thank you. You can lower your hand. If you have any doubts, please ask, or else you can lower your hands. Okay, Priya and Krish, you can lower your hands. If you have any doubts, you can unmute and ask your question. Krish, you can also lower your hand. If you have any question, please unmute yourself and ask. Okay. So I presume there are no doubts here. So again, you can solve this using your determinants. Using your D, D1 and D2, you can find out your currents. Okay. And similarly, after that, you can find out the currents to the individual resistances. So again, since we have this 2-hour session, we would not be able to calculate this. I'm sure you can perform this particular task whenever you get the presentations, you can start calculating and practicing this type of questions. Okay. Now we'll move to nodal analysis. So when we talk about nodal analysis, we'll be applying KCL here. As far as mesh analysis were concerned, we were applying your KVL. Here we'll be talking about your KCL and we'll applying that here. Now let's have a look at the question. Now just try to understand the figure for. Here, as you can see, there is a current which is moving here in the upward direction, which is given to you, which is 3.1 amperes. Here the current is moving in downward direction and the value is minus 1.4 amperes. Now we have just seen in numerical that if the value of current is negative, so that means that the current is moving in opposite direction. So here, can we consider that the current is moving in upward direction and the value is 1.4 amperes? So here what you need to figure out is you need to find out first the nodes where you will be applying your nodal analysis. So here you can find out three nodes. One is this node, other is this node, and third is the bottom node. So there is no elements here. So you can see all these particular 4 points are connected at one particular place. Fine. So here what we'll do is just give me a second, please. Okay, sorry. So here, as we can see that the three nodes are formed is A, B, and C. And now since it is nodal analysis, we'll perform the nodal analysis on these three nodes, that is A, B, and C. Since the C node is taken as reference node, you always need a reference node because when you're measuring voltage, you find voltage with reference to something. So here when we say that C is your reference node, so the voltage at node A, let's call this as VA, and the voltage at node B would be VB. So that is with reference to your reference node C, which would have a voltage of 0. Okay. So here, if we need to apply the KCL, we need to know what is the entering current and what is the leaving current. So here, if I say the 3.1 ampere is entering my node A, it would leave node A by the two branches which is connected between A and C and A and B. Okay. Similarly, the current is minus 1.4 amperes going in downward direction. So the resultant current would be going in upward direction with an amplitude of 1.4 amperes. So 1.4 amperes is entering node B. So it will leave the current through the two branches, that is B to C and B to A. Now here, right now, we do not know the amount of current which is flowing from A to B. That is why we are taking both the directions. That the current is also moving from node A to node B and the current is also moving from node B to node A. Actually, the overall current passing through 5 ohms resistance, which is connected between node A and node B, is nothing but the resultant current between these two currents. So let's try to write this in terms of equation. So 3.1 ampere is equal to this current plus this current. So if I write down, let's say this 3.1 amperes is, let's call this current as I1 and this current as I2. So can I say my 3.1 amperes is equal to I1 plus I2? Do you understand this? Can I say my 3.1 ampere current entering the node A is equal to I1 plus I2, which is the current leaving the node A? Is this clear? Any doubts here? Okay, fine. So let's move ahead. Since I1 plus I2, now I want to write this current in terms of voltage. So I can write VA minus VB, that is the potential in this particular branch, VA minus VB divided by the resistance 5 ohms would give me my current I1. Similarly, the current I2 is voltage VA minus voltage VC, that is the voltage in this particular branch across 2 ohms resistance divided by the 2 ohms resistance would give me the total current. So V is equal to I into R. I want I, so it would be V by R. So the same process we are following here, where V is the voltage VA and VB. So VA minus VB divided by the resistance of 5 amperes would be my I1 plus VA minus VC divided by 2 ohms resistance would be my I2. Similarly, if I talk about the current entering here, so 1.4 amperes is entering B, would be equal to, let's call this current as I3 and this current as I4. So that means my 1.4 amperes is equal to I3 plus I4. Okay. So when I talk about 1.4 amperes is equal to I3, what is I3? I3 would be VB minus VC by 1 ohms. So again, converting my current in terms of voltage and resistance. So that would be VB minus VC upon 1 ohm. And similarly, my I4 would be VB minus VA upon 5 ohms. So when you're writing the equations for node A, your primary current would be, your primary voltage would be voltage at node A. So this would be VA minus VB upon 5 ohms when you're talking about current I1. But when you're talking about current I4, your primary node is B. So this would be VB minus VA divided by 5 ohms resistance. Okay. So this is how you will get your two equations. Once you have your two equations, again, you can put this in form of matrix and then again apply your determinants, find out your D, D1, D2 and calculate the values. Okay. So now, as far as the question is concerned, you are asked to, let us see what is asked. You need to find out the voltage across 5 ohms resistance. So by using this, you have two equations with two unknowns VA and VB. Solving this either by Cramer's rule or by elimination or by substitution, you will find out your VA and VB as 5 volts and 2 volts. So the voltage across 5 ohms resistance would be VA minus VB, that is 3 volts. Okay. So I hope this is clear to you. Now I have another question here and there are the answers are given to you, but I don't want you to solve the answers right now. I want you first to make the equations. Okay. So I give you 2 minutes time. Start forming the two equations for your nodal analysis. Okay, have we written the equations? Okay, now let us have a look at the answer. So here again, I'm assume that you might have taken three nodes, considering the top of the 7 ohms resistance as node A, the top of 10 ohms resistance as your node B, and the bottom of both the 7 and 10 ohms resistance as node C. So at node A, the equation would be 8 amperes, that is the current which is entering into the node. So 8 is equal to, it is dividing into two parts, that is current through 5 ohms and current through 7 ohms. So that would be VA minus VB divided by 5 plus VA minus VC divided by 7. Is this correct? How many of you are getting this equation correct? 8 is equal to VA minus VB by 5 plus VA minus VB by 7. If you have any doubts, please ask. Okay, let's talk about the second equation. The current entering into the node B is 5 amperes. It is leaving into two branches, that is 5 ohms and 10 ohms. So the current through 5 ohms resistance would be VB minus VA upon 5. Why VB minus VA? Because your B node is the primary node. So that would be VB minus VA divided by 5 plus the current through 10 ohms resistance would be VB minus VC by 10. So 5 is equal to VB minus VA by 5 plus VB minus VC by 10. Is this clear? Any doubts, please ask. Okay. How many of you still have problem in understanding these equations? Please raise your hand. If you have any problems in understanding how to form these equations, please raise your hand. Okay, perfect. Since we don't have any hands raised, so I want you to solve this equation and find out the answers. So here, the answer for VB, you might get this as 52.72 instead of 27. The right answer is 52.72. So there is a small misprint here, which you can rectify it at your end. Similarly, we have this third figure. Now I want you to understand that how will you form equations for this particular figure. Take your time and figure out the number of nodes and write the equation for these particular nodes. I give you 3 to 4 minutes time to understand how you will write this particular equations. Okay. Take your time, make sure rather than being fast, you are paying attention to the details and writing the correct equations. Okay. Think twice before writing your equations, but make sure your equations are correct. All the best. Okay. If you have difficulties in writing the equation, I'll give you the next step, which might help you in solving this. So consider this as your hint number one. And now think, how will you form the equations? Here the nodes are taken as 1, 2, 3, and 4. You can take it as A, B, C, and D. That's your call. You can give whatever names you want to your nodes. That's up to the person who's solving it. Another 2 to 3 minutes time to write your equations, and then we'll see how to solve this. Okay, so I hope you are able to write the equations. So let's talk about the equation which is here at node A. So please understand that the equation when you write, the total number of wires connected at that particular node would be the amount of elements that you have in that particular equation. So here when you see at node 1, there are 4 wires which have been being connected. So you will have 4 terms in that particular equation. So now let us understand this. When you are applying KVL at this particular node 1, so the current entering is 10 amperes. So your 10 amperes is the entering current, which would be equal to your current which is leaving. That is I1 plus I2 plus I3. So you can write this equation as 10 is equal to, where I1 is equal to V1 minus V4 by 2 plus I2 is equal to V1 minus V2 by 3, and I3 is equal to V1 minus V3 by 5. So this would be the equation for your node 1, where I2 would be V1 minus V2 by 3, I3 would be V1 minus V3 by 5, and I1 would be V1 minus V4 by 2. Any doubts here? Any doubts here? Please ask. Okay. So now moving to your next node, that is node number 2. So if you're writing equation for this node 2, the current that is entering is I2 and the current that is leaving is I5 and I4. So again, three wires are being connected with your node 2. So the equation would have three elements. So current entering I2 is equal to I4 plus I5. So I2, which is nothing but V1 minus V2 by 3. Now here we are not taking V2 minus V1 by 3. We are taking V1 minus V2 by 3. Why? Because we know that the direction of current here, the current direction is moving from terminal 1 to terminal 2. So that is why it would be V1 minus V2 by 3. That is the incoming current plus the outgoing current, that is I4, that is V2 minus Hello, am I audible? Students, am I audible? Okay. Sorry, I lost my connection. So let me just. Can anyone unmute yourself and tell me what was the last thing that you heard?
Sir, we were analyzing the node 2.
You were analyzing the node 2. Okay. So let me go back to the. Okay. So you are analyzing node 2. So my as far as node 2 is concerned, see, understand here that the overall current is 10 amperes that is entering from the left hand side, and 2 amperes is what is leaving from the right hand side. So all the current is moving from left to right. The entire current is moving from left to right, and 2 ampere, which is surplus, which is leaving your node 3, and that is how your circuit is performing. So you should understand that all the currents is moving from left to right. So when we talk about node 2 as well, the current entering is I2, whereas the current leaving the node is I4 and I5. So when you talk about node I2, node 2, the current entering I2 would be V1 minus V2 by 3. Since we know the direction of the current I2, it would be V1 minus V2 by 3 plus the current leaving, that is I4 and I5. So I4 would be V2 minus V3 by 1 plus I5 would be V2 minus V4 by 5. Okay. So since you have three connections here at node 2, you'll get three terms in this particular equation. Similarly, talking about your node 3, you can see that there are four wires connected to this particular uh, junction, or say this particular node. So again, you'll have four terms for this particular node. So let's see the incoming currents and the outgoing currents. So here the incoming currents would be I3 and I4. If you can figure out, this is the I3 which is moving to this particular node. I4 is moving to this particular node. So I3 and I4 are the incoming currents, whereas I6 and I2 are the currents that are leaving this particular junction. So when we talk about I3 would be I1 minus I3 upon 5. Since the current is moving from junction 1 to junction 3. So the current moves from higher potential to lower potential. So that would be V1 minus V3 upon 5. Similarly, the incoming current I4 is moving from V2 to V3. 2 minus V3 by 1, that is my I4, which is equal to the current leaving, that is I6, that is V3 minus V4 by 4 and plus 2 amperes. So these are the two currents that are leaving the junction. So these are the three equations that you can see for this three particular nodes, 1, 2, and 3. So are you able to understand these particular nodes? If you have any doubts, please ask. Any doubts in the three equations that we have formed? Okay. Since I don't see any hands raised, so I presume that there are no doubts and you have been able to solve these equations. So again, now you have three equations with three unknowns, V1, V2, and V3. So again, finding out your determinant and finding out your V1 by uh, solving the determinants and taking D1 by D, D2 by D, and D3 by D, you will find out your V1, V2, and V3, which will give you the voltages. And once you have the voltages, you can figure out the currents through each particular resistance. So this is how you will be solving this particular numerical. Okay. Next, we'll like to move to series and parallel. But before we move to series and parallel, anyone has any doubts with nodal analysis? Please raise your hand. If you don't have any doubts, you can write no doubts in the comment section. You're up. That is up to you. If you don't have any
Sir,
doubts, please. Yes, Marut, go ahead.
sir, nodal 3 equation.
Nodal 3. Okay. Okay. Can you see my pointer, the red color dot?
Yes,
Okay. So if you see that node 3 has four wires which are connected to this, four wires connected
yes,
to node 3. Okay. Now
yes,
in this four wires, can you see I3 and I4 are traveling towards the node?
yes,
Yes, that would be the same current leaving the node, that is I6 and 2 amperes.
yes,
So I3 plus I4 would be equal to I6 plus 2 amperes.
yes,
Is this clear? Okay, so I3 would be current is moving from node 1 to node 3. So higher potential to lower potential. So V1 minus V3 divided by 5. Similarly here, current is moving from 2 to 3. So this is at higher potential, this is at lower potential. So V2 minus V3 by 1. This is equal to my 2 amperes current plus the second current leaving is I6, which is V3 minus V4 divided by 4. Is this clear?
Yes.
Okay. Any doubts? Any further doubts? Please ask. Any further doubts with nodal analysis? Please ask. Okay, great. Since I don't see any hands raised, I presume that there are no further doubts with this particular technique. So now next we'll move to your simple series and parallel combination. So this is something that you have already studied in your previous standards. If your resistances are in series, the equivalent resistance is simply adding all these three particular resistances. If you have n number of resistance, you will add all those n number of resistance and you will get your equivalent circuit. If they are in series, the current flowing through the resistance would be same. So your R equivalent would be equal to V upon V1, but the voltage drop across all the resistance would be different. So you have as V1 plus V2 plus V3 upon I. Again, considering this, now there is a small typographical error here. This has to be I and not I1, I2 and I3. So using this, you can convert this into R1, R2 and R3. Okay. Similarly here, if the resistance are in parallel, the voltage across the resistance remains same, but the current through all the resistances would change. So for finding out R equivalent, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, how did you come to this equation? So your V upon R equivalent is equal to the total current I. Now the total current I is equal to the sum of all the branch currents, that is I1 plus I2 plus I3. Depending on the number of branches, you have to add all those currents. Now here the current I1 would be equal to V by R1. Now since the voltage in parallel is same, this all this V1, V2, V3 would nothing but V. So that would be V is taken out common, so V and V get simplified. So 1 upon R equivalent becomes 1 upon R1 plus 1 upon R2 plus 1 upon R3. So if you are asked to prove that the R equivalent in series is R1 plus R2 plus R3 and R equivalent is parallel is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. You can do this by showing this particular derivation. Okay. Moving ahead, you can go through this whenever you have the PPT. Now let us try to solve this. You need to find out this particular value of unknown resistance. So I'm sure you are able to figure out this. All these three resistances are in parallel. Both these two resistances are in parallel and this one resistance. So this combination is in series with this combination, is in series with this combination. And this entire combination is in parallel with the unknown resistance R. Okay. So first you will have to solve this. You will have to figure out your unknown. For calculating your unknown resistance, you will need your circuit current, which is given that the current supplied by the battery is 5 amperes. So the overall voltage, overall current is given to you. And based on that, you can figure out your equivalent resistance. Okay. So we are not getting into calculations, but I hope you have understood this. So that 4 ohms, 10 ohms, 20 ohms, all these are parallel. This combination is in series with the combination of 2 ohms and 3 ohms, which are in parallel. So first combination in series with the second combination in series with 2.3 ohms. These three are in series, which is in parallel with R ohms, and it is supplied by the voltage of 15 volts with a total circuit current of 5 amperes. Okay. So you can find out this. You can take the snapshot of this and I'll also share the answer with you. You can calculate and figure out your answers. So the overall answer to this is unknown resistance is 6 ohms. Okay. So let's go through this And talking about the next type of, again, here you can see that your 20 ohms and 30 ohms are in series. Similar, that is between node F and D. Similarly, node between node G and D, you can see 40 ohms and 10 ohms are in series. So combining this, you get this. Similarly, between C and G, you can see 15 ohms and 10 ohms are in series. Post this, now you don't know what is in series, what is in parallel, and you will not be able to figure out until and unless you rearrange this particular figure. Now, if you see that this symbol indicates that there is a crossover. So what is the difference between a crossover and a junction? So when we talk about crossover, the wire is moving over the second wire. So there is no electrical connection here. There might be a mechanical connection where the one cable is moving over the other cable. They might be mechanically connected, but they are not electrically connected. So the current will not be divided. If the current is moving from C to G, it will not go in the wire which is connected between F to G. Fine. Also, if you can see that between nodes C and D, there is no element connected. Similarly, between F and G, there is no particular element connected. So I can rearrange this figure such that C and D are at the same node and F and G are at the same node. So if I rearrange this, my figure would look something like this. So now once you have rearranged this figure, you can see that your 50 ohms is in parallel with 25 ohms and 50 ohms. Once you solve this, you will get your overall resistance as 12.5 ohms. 50 parallel 50 is 25 and 25 parallel 25 is 12.5. 10.5 would be in series with this 2 ohms and 8 ohms. So this entire section would be 12 plus 10, 12.5 plus 10, that is 22.5 ohms. So that is how you'll be able to solve this. Moving ahead to the next question, again, now you can have such type of questions asked in the MCQ as well as the same type of questions can be asked for 5 markers as well. Now, if you can see, you might think that this is a difficult question, but actually, if you spend a couple of seconds looking at the diagram, you would feel that no, it is not. Let us see how. Let's start solving. See, you need to find out resistance between terminal A and B. So you start solving from the opposite end to these particular terminals. If you see, the resistance between K and C is 25 ohms and the resistance between C and D is 75 ohms. And both these resistance are in series. So 25 plus 75 would be 100 ohms. Now this 100 ohm is in parallel with this particular 100 ohms. So 100 parallel 100 would be 50 ohms. This 50 ohms would be in series with this 50 ohms. Okay. So here you have this as this 50 ohms is in parallel, is in combination with this 100 parallel 100, that is 50 ohms. Okay. So this 50 and 50 are in series. So this 100 parallel 100 would be another 50. So this would look something like this. Now again, you have this 50 parallel, 50 in series with 50. So that is 100 ohms. 100 parallel 100 would be again 50. And so the last part that you get is something like this. So 25 plus 50 is the 75 ohms as your final answer. So you might find that these are difficult questions, but once you try to understand the figure, it becomes comparatively very easier. Here again, you need to find the resistance between terminal A and B. Now just have a look at this. If you need to find out the resistance here, you start from the opposite end, that is this end. If you see, my 3 ohms between A and C is in series with 3 ohms between C and D. So 3 plus 3 becomes 6. 6 parallel 6 again becomes 3. Then the resistance, overall resistance between A and D becomes 3 ohms. 3 in series with the 3 ohms resistance becomes again 6. 6 parallel, this 6 ohms resistance between A and D again gives me 3 ohms as the equivalent resistance between A and D. So again 3 ohms with series with EF, that is 3 ohms. So again this particular resistance 3 plus 3, that is 6 ohms. Parallel 6 ohms with A and F gives me the equivalent resistance of 3 ohms. And A and F is again 3 ohms in series with 3 ohms, that is 6 ohms. So 6 parallel 3 is the final, excuse me, is the final resistance between terminal A and B. So once you solve this, you'll get your final answer as 2 ohms. So again, I would like you to take a snapshot of this and try to solve this particular numerical so that you have an clear view of how you can solve such type of questions. Okay. Similarly here, in this particular numerical, try to take the snapshot first and then we'll try to solve this. Here it has been asked that what is the current through the branch AF. So that means we need to find out the current that has been supplied by the battery or supplied by the voltage source 22 volts. So here if you can see this 5 volts and 9 volts are in series. So 5 plus 9 is 14. 14 parallel 14 will give you 7 volts. 7 ohms. This 7 ohms is in series with 11 ohms. So 7 plus 11 is 18. 18 parallel 18 would give you 18 parallel 18 would give you 9 ohms. 9 is in series with 13. So 9 ohms in series with 13 ohms is give you 22 ohms. 22 ohms parallel 22 ohms will give you 11 ohms as your answer. So your equivalent resistance is 11 ohms. Your voltage is 22 volts. So I is equal to V by R. So 22 by 11 that gives you 2 ampere as your final answer. So you can do such short calculations if it is asked for 2 marks. But if the same question is asked for 7 marks, you'll have to draw the diagrams at each and every step so that the examiner understands and it is justifiable to give you the complete marks if you have drawn the diagram at each and every steps. Also make sure that whenever you write your answers, whether it is resistance, whether it is voltage, whether it is current, please make sure that you have written units with your particular answers so that there is no scope of deduction of marks at any particular step. Make sure you have written your formulas, make sure you have written your units. That helps the examiner understand that how you have reached a particular step. Fine. So I think we'll end here. The next what we have is star delta transformation. So we'll take this up in the next lecture whenever it is being scheduled. So I just wanted to ask if anyone has any doubts in whatever we have discussed so far, please feel free to share your doubts or any particular thing that you would like to share. I would any particular feedback for the particular session if you would like to share. I would be more than happy to understand that how did you find the session? Was it too fast? Was it too slow? Were you able to understand? Was there anything that you would like to add in the next sessions? Please feel free to share your views. You can also unmute and answer just in case if you don't want to type it out. You're free to unmute and answer as well. We'll just take last 1 minute for the feedback. Any particular further things if you'd like to add? Okay. So I think we are already crossing our timelines. So let's end the session here. Thank you so much for joining and